One other indeterminate form that we do have is infinity minus infinity. That's an indeterminate form. You might be saying, well, looks like zero to me.
You don't know which infinity is getting bigger faster.
Yes, a lot of times it depends on the largeness of your infinity, or how fast infinity is growing there, but it's indeterminate. It may be zero, but it may not be zero as well. A couple of examples of what we can do here. All right, so again, let's do a limit as x approaches 0 from the right. So we got 1 over sine of x minus 1 over x. Well, individually, these are, we can determine what, so we've got 1 over sine of 0, that's 1 over 0, isn't it? 1 over 0, and we mentioned that earlier. 1 over 0 can either go to infinity or minus infinity. I believe here we're going to infinity, so this is infinity. 1 over x, again, 0 from the right, so that's infinity, so we've got infinity minus infinity. 1 over 0 minus another 1 over 0. Turns out that one's an infinity minus infinity. It's indeterminate. What do we do? Well, if we've got one like this where we have the fractions, the good news is try combining the fractions. Combine it into one expression. In other words, get a common denominator here. In this case, we can do that. All right, so multiply by x over x here, and then 1 over x multiplied by sine of x over sine of x. And that'll get me x over x sine of x minus sine of x over x sine of x. So see what I'm doing here? Making it where I combine the fractions into one fraction. So it's just limit as x approaches 0 from the right. So we have x minus sine of x over x sine of x. Yeah, so since I've got a common denominator now, those can be combined into one expression, one fraction. Okay, with me there? So far so good. All right, well, again, the goal here is we combine it into one fraction. Guess what we can do now? Well, x goes to 0, 0 minus 0 over 0 times 0. It's 0 over 0 form, isn't it? We've got our 0 over 0 form, which is where we can apply L'Hopital. So that's the limit as x approaches 0 from the right. So L'Hopital, derivative at the top, 1 minus cosine of x. Yeah, you could run into product rules and other things. So here's a product rule. Yeah, so we got to do the product rule 1 times sine of x plus then reverse that to be x times cosine of x for the derivative of that. Does that sound right? Yep. Believe that? Okay. All right, so let's see. Oh. Well, did that do anything? X goes to 0, so we got 1 minus cosine 0. 1 minus 0. 1. I mean 1 minus 1 is 0. And then 0 plus 0. All right, so we didn't accomplish anything. We still have 0 over 0, but unless we can tell, we're not going anywhere with this. Let's try L'Hopital again. So that's limit as x approaches 0 from the right. All right, this is work. Yeah, it did work out because now we're we're just a sine of x on top. On the bottom, what we got? Cosine of x. Now we do have to do a little product rule there. 1 times cosine of x plus x times the derivative of cosine of x minus sine of x. I think we're good. Top goes to 0, but what does the bottom go to? 1 plus 1 plus 0. 0 over 2. That's not indeterminate, is it? So it's just what you thought. Infinity minus infinity is 0. Might not always be the case, but that case it was. Just just to show you that infinity minus infinity is not always 0, let me show you another one. It's the last example here. So we'll get on that one. How about the limit as x approaches 1 from the right, 1 over x minus 1, minus 1 over x squared times x minus 1. Yeah, you might have to look at the graph to see, use that to give you some idea of what that limit might be. 1 over x, yeah, it's going to be infinity. You've got a vertical asymptote, and then from the right it's infinity. And then same thing over here, it's still infinity. For that limit, so we've got infinity minus infinity. Indeterminate. So let's combine them into one single fraction, 1 over x minus 1. All I have to do is multiply this one by x squared over x squared. And that'll make it the same denominator as my other one. So I've got limit as x approaches 1 from the right. So it'll be x squared minus 1 over x squared times x minus 1. Because I'll have a common denominator there. Is everybody okay with that? Now, there are a couple ways we can go with that, but it is L'Hopital, isn't it? If the top is 0, the bottom is 0, if x goes to 1. It saved me do the product rule, but saved me a little bit. Here, let's go ahead and write, before I L'Hopital, make an x squared minus 1 over x cubed minus x squared. Go ahead and multiply that out. So a L'Hopital here, I've got two x over 3x squared minus 2x which is 2 over 3 minus 2. 2. Infinity minus infinity is 2 in this particular case. Just never know. Okay.